All right, we are back with example 2, solving equations using division. So we're going to solve each equation, check your answer, and remember to write that original equation whenever you do the check. Okay, so our first problem we're going to look at is 7x equals 56. We are trying to get x by itself. Is x by itself? No, it is not. So we're going to have to get x by itself. There's a 7 there. It's related to x through multiplication. So we have to do the inverse operation of multiplication, which would be division. So we're going to divide both sides by 7. 7 divided by 7 is 1. 1 times x is just x. So now x is by itself. And 56 divided by 7 ends up being 8. X equals 8. All right, now let's go ahead and check our solution. So we're going to write down that original equation, 7x equals 56, and substitute that 8 in there, 7 times 8. So we want to see if this is true. 7 times 8 is 56. So that is a true statement, which means our solution, x equals 8, is the solution to this original equation. All right, let's move on to the next one. 14 equals a negative 2w. So we are trying to isolate w and get w by itself. Now there's this negative 2 multiplied by w. So since it's being multiplied, we're going to have to do the inverse operation of multiplication, which would be division. And we're going to divide by whatever this number is. So this is a negative 2, so we're going to divide by a negative 2 to both sides. When we do that, a negative divided by a negative ends up being a positive. 2 divided by 2 is 1. 1 times w is just w. And then over here, we have a positive divided by a negative, so we know our answer is going to be negative. And then 14 divided by 2 is just 7. Now I'm going to use that symmetric property of equality to go ahead and switch it. So we have w equals negative 7. But we're going to go ahead and check it. So write that original equation, 14 equals negative 2w. All right, now we're going to substitute negative 7 in for w. And whenever you substitute a negative value in for a variable, you always put it in parentheses like that. Okay, so there's nothing to do here, so I'm just going to rewrite this 14. So we have a negative times a negative. A negative times a negative is a positive, right? And 2 times 7 is 14. So there we have it. We have a true statement, which means our solution is the solution to that equation. All right, perfect. Let's move on to C. So on C, we have 16 equals 4c. We're trying to isolate C and get it by itself. So is it by itself on this side of the equation? The answer is no, it is not. It is being multiplied by 4. So we have to do the inverse operation of multiplication, which would be division. So we're going to divide both sides by 4, right? 4 divided by 4 is 1. 1 times c is just c. So then we have 16 divided by 4, which ends up being 4. And I'm going to use that symmetric property of equality again just to flip-flop that. C equals 4. Okay, now it's time to check. I'm going to write the word check so everybody knows that I'm checking my problem now. I'm going to write that original equation. And then I'm going to substitute 4 in for C. So I'm going to go 16 equals 4 times 4, just like that. And there's no reason why I put in parentheses. Sometimes I like doing parentheses. Sometimes I just put a dot. But whenever you do a negative number, you always want to put in parentheses. So here we go. 16, nothing to do over there on this side. But over here, 4 times 4 is 16. So that is a true statement, which means our solution is the solution to this equation. All right, one more. 0.5y equals negative 10. So we're trying to isolate y, get it by itself. Right now it's currently being multiplied by 0.5. So the inverse operation of multiplication would be division. So we're going to divide both sides by 0.5 like that. 0.5 divided by 0.5, that's just 1. 1 times y is y. Equals negative 10 divided by 0.5. So I'm going to go ahead and do this little long division over here. But for right now, I know a negative divided by a positive is going to be a negative. My answer is going to be negative. So I'm going to go up here and go 10 divided by 0.5. Okay, The first thing is whenever you're dividing by decimals is you have to know you can never divide by a decimal. So we have to get rid of the decimal. So I'm going to move this decimal place over 1. And when I do it here, I also have to, there's a decimal, I'm going to have to move it over 1 place here. So really now what I'm dividing is 100 divided by 5. So 5, does it go into 1? No. Does it go into 10? Yes, 2 times. 2 times 5 is 10. No remainder, but we dropped that 0 down. Does 5 go into 0? No, it doesn't. 0 times 5 is 0. No remainder. Boom, we're done. So it goes in 20 times. So 10 divided by 0.5 is 20. And a negative divided by a positive is a negative. Okay, then we're going to do the check. So write down the original equation. And then we're just going to substitute that negative 20 in for y. And remember, we're substituting in a negative number, so we need to go ahead and write that in parentheses. Okay, now we just need to do this work. So like I said, I'm going to go up here and do a little work up here. So we have 20 times 0.5. Right? Okay. So I'm going to do the multiplication. 5 times 0 is 0. 5 times 2 is 10. And then that's just a 0, so we don't do anything. And then we need to count up the decimal places. There's 1 decimal place, so I move this over 1 place, which means it's 10. So the answer is 10. And then a positive times a negative is a negative. So we got the same thing. Negative 10 equals negative 10, which is a true statement. You always want to make sure you do the work, okay? You never want to take this number and then just write it down there. That's called cheating, okay? So on all of these, you actually need to do this work and prove that that answer is actually negative 10. So awesome job on example 2. We'll see you in a little bit for example 3.